Welcome back to the deep dive. If you, like a lot of us, just assumed the week between Christmas and New Year's was dead quiet.
A perfect time for a holiday, right?
Exactly. But you definitely weren't working inside Google AI. What we saw during that brief stretch, specifically December 28th to January 4th, wasn't just a trickle of minor updates.
No, not
It was
quite.
a sharp, really strategic consolidation of some massive frontier AI launches.
That's the critical takeaway here. This week, it wasn't just housekeeping. It was basically a formal declaration that we've transitioned into what we're calling the agentic era.
The agentic era. So what does that mean exactly?
It means the entire focus has shifted.
Yeah.
It's no longer just about interacting with a sophisticated chatbot.
Right.
It's about establishing these robust, autonomous systems that can execute complex, multi-step plans on your behalf. Whether you're a consumer looking for, a better search result or a global enterprise managing critical infrastructure.
And all of this is sitting on top of massive infrastructure and, as you said, verifiable reasoning.
Precisely.
And that's our mission today. We are peeling back the layers on Google's AI updates from that crucial week, trying to connect the dots between the research, the global product deployments, and of course the cloud architecture that has to be in place to handle this kind of scale. So let's start at the foundational level. How do you convince a user or a developer to truly trust an autonomous AI agent?
Well, to trust an agent with a really complex task, let's say managing your investments or protecting a corporate network,
Yeah.
you need more than just a good answer.
You need to know how it got there.
You need a transparent audit trail.
Yeah.
You need to know why it did what it did.
Yeah.
And this brings us right to the fundamental challenge that the research arm of the organization has been tackling.
Okay, so the big headline here is the AlphaGeometry 2 JMLR publication from Google DeepMind. This was formalized in the first week of January. This isn't something the average consumer is going to download, but it feels like it sets the standard for the next decade. Google formally published AlphaGeometry 2 in the Journal of Machine Learning Research. And the key thing, they released the code for its symbolic reasoning engine. They call it DDAR.
Deduction, database, and algebraic reasoning. And what's so fascinating here is how this architecture solves that core problem of reliability. Most of these current large language models are, they're probabilistic. They predict the next most likely word or step.
So it's inherently messy.
It's inherently messy. AlphaGeometry 2 is designed to bridge that, to connect the messy, probabilistic nature of the neural networks with pure deterministic logic.
I get that it's intellectually amazing, and DeepMind is definitely flexing its muscles here by having an AI solve international mathematical Olympiad geometry problems, but does a regular user of the Gemini app really care about that?
That's a fair question.
Or is this just academic curiosity? How does this research directly improve my daily search query?
It improves it by ensuring consistency, especially in high-stakes areas. Demis Hassabis, the CEO of DeepMind, often talks about jagged intelligence.
Okay, what's that?
It's when an AI system is brilliant in one area, but then fails at basic logic in another. AlphaGeometry 2, DeepMind's answer to closing those reasoning gaps. So think of DDR, that symbolic engine, as a kind of high-speed, formal calculator. It's designed to check the messy, creative work that the neural network suggests.
So the neural net has an idea, and DDR checks its homework.
That's a perfect way to put it. The neural model proposes a geometric construction, and DDR rigorously verifies it. This makes sure the final output is a human-readable, verifiable proof, not just a good guess. And that capability is absolutely critical for agents in medicine or legal or security. It moves the whole field from guessing to proving.
Okay, so that crucial research piece is in place. Verifiable proof is now possible. So the next logical question is, how quickly do they push that foundational trust into real products for consumers and developers?
The answer is instantly. The biggest global product action we saw happened on December 29th.
Right. That was the Gemini 3 Flash global default rollout confirmed by Google AI. They put out a monthly recap confirming that Flash is now the default model in the Gemini app and in AI mode in search.
And the main value prop there is speed and cost efficiency.
But also scale.
And scale. Oh, the scale is the big story. This is not just an upgrade. It's a massive strategic deployment. It democratizes frontier intelligence. I mean, get this. The Gemini 3 API has been processing over 1 trillion tokens per day since it launched.
1 trillion a day. Wow.
By making Flash the default in the app and AI mode in search, rolling it out across about 120 countries, Google is ensuring that this cutting-edge, fast AI reasoning is the new baseline for billions of users.
And the power of that agent architecture is also flowing directly to developers, isn't it? We saw the Deep Research Agent and DeepSearchQA benchmark released on the same day.
We did. The Gemini Deep Research Agent was made available to developers through a standard API key.
What does that signal?
It signals they're not hoarding their most sophisticated agent tech anymore. When we talk about a deep research agent, we mean an AI that can break down a really complex, open-ended question into, say, 10 or 15 different web search steps, execute them, filter the results, and synthesize a final report.
And giving that to developers means...
It extends true agentic capabilities to any third-party app.
And what about that benchmark, the DeepSearchQA?
That's the industry governance piece. By open sourcing it, Google is basically standardizing how these complex multi-step research agents are evaluated. It drives accountability and lets competitors measure their agents against Google's standard. It fosters transparent competition.
So beyond developers, we also saw some really tangible consumer improvements, right? Leveraging these new imaging models.
Yes.
This update solves a huge pain point for online shopping. Virtual try-on gets selfie-based full body generation. US shoppers can now just upload a simple selfie.
Which is a classic example of using advanced AI to reduce consumer friction. Think about the computational challenge there. A selfie is just a 2D image, the lighting is all over the place, there are wrinkles in your clothes, background noise.
It's a mess.
It's a mess. And the Nano Banana Pro model is what makes this work. It takes that basic 2D input and generates a realistic, studio-quality, full-body digital version of you draped in whatever you want to try on.
So it's solving the I hate dealing with returns problem by solving a digital geometry problem first.
Precisely. By lowering the barrier to entry so drastically, this tool connects more casual shoppers to the billions of products in the shopping graph. It drives conversion, and you'd have to think it reduces those costly returns.
And speaking of seamless integration, let's switch to enterprise data. On January 3rd, Google Cloud announced that BigQuery adds the AI.GENERATE function.
This is a really big deal for data scientists.
Why is that?
Well, before, you might analyze your sales data in BigQuery. Then you'd have to export it, run it through a separate API call to Gemini for, say, a qualitative analysis, and then bring it all back.
A lot of steps.
A lot of steps. Now, you can just write a standard SQL query, the language of data, and tell it to generate a 3-paragraph summary of customer churn. You're embedding generative AI directly into your normal data analysis workflow. It just massively streamlines everything.
It's easy to focus on the features and the models, but none of this trillion token a day processing is possible without the sheer underlying engineering.
Not at all.
Which brings us to the core question of scale. How are they actually building the foundation to run billions of agents globally?
This is where you see the long-term strategic investments become really clear. The week saw a massive $4.75 billion agreement for the Intersect acquisition for AI data centers.
$4.75 billion, just to secure power. Is this just about keeping the lights on, or is it a strategic move to lock up the non-chip limiting factor against competitors?
It's both. It's absolutely both. This investment secures gigawatts of energy. It confirms what a lot of experts have been saying for a while now.
Yeah.
The limiting factor for true long-term AI scale isn't the highest-end chips anymore.
It's power.
It's sustainable, high-volume energy access. By locking this up, Google is signaling its commitment to long-term dominance.
And at the same time, they're optimizing how that power is used. We saw the very technical but very important Google Kubernetes engine, or GKE 1.35, released on December 29th.
Right, in the rapid channel. And these structural changes are critical for efficiency, especially for these new agentic workloads.
So break that down for us. What does something like in-place pod resize actually mean?
Okay, so simply put, it means if your AI agent suddenly needs more computing power to handle a complex task, the system can instantly give it more RAM and CPU without forcing the application to stop and restart.
So no more crashing when the agent gets busy.
Exactly. This dynamic adjustment and the secure isolation, which is handled by mandating something called C-Group v2, are essential for running the fluctuating demands of these multi-agent systems we've been talking about. It means lower latency, higher reliability, and ultimately, it reduces cloud spend for enterprises.
They also released the TPU v6e training guide on January 2nd.
Yeah, and that step focuses more on the manufacturing efficiency side. It's documentation on how to train models using their 7th-generation tensor processing unit. It's a vertical integration move that optimizes their own compute infrastructure, which reduces the cost of training the next generation of Gemini.
With all this power and scale hitting the market, how does Google manage the guardrails? Let's wrap up by looking at safety, governance, and enterprise adoption.
Right. The first step is providing tools for transparency, which is key to securing market position in the age of deepfakes. So on December 29th, the Synthid video verification launched in the Gemini app.
Okay, so if I upload a video I think is suspicious, what is the app actually checking for?
It's looking for Synthid's imperceptible watermarks. You can upload videos up to about 100 megabytes or 90 seconds. The system analyzes both the audio and the visual tracks, that's important, to detect any Google AI-generated content.
It's trying to get ahead of authenticity concerns.
Proactively, yes.
Yeah.
By pinpointing specific AI-generated segments, it reinforces trust in what you're seeing and hearing.
And on the education front, there was a clear strategic rebranding on December 30th. Gemini Education was renamed to Google AI Pro for Education.
This is about eliminating tiered access for institutions. The change aligns educational tools with the highest consumer and developer tiers. It makes sure that students and educators get access to the latest frontier models, specifically Gemini 3 Pro and Nano Banana Pro.
So it's not just an experimental add-on for academia.
No, it signals that for Google, AI is a core professional component of education.
And finally, to formalize the business side of things, we saw the introduction of the Vertex Gen AI offer 2025 Syncs Use on December 30th.
Right. If you're a developer building on Google Cloud, this introduces new structure keeping units, or SKUs. It provides updated pricing and tooling options for everything from the Vertex AI platform to Studio and Agent Builder. It just clarifies the monetization strategy and makes it easier for big companies to budget for and deploy these agent services.
So pulling all these threads together, that week was anything but quiet. We saw the global deployment of Gemini 3 Flash. That's pure scale, pure democratization. We saw the deep commitment to verifiable reasoning with AlphaGeometry 2, which is all about trust. And the infrastructure investment from the Intersect deal to the GKE optimizations confirms they're building for exponential scale. The agent is definitely the new atomic unit of computing for them.
Absolutely. The agentic era isn't just some marketing phrase. It's a reality being supported by a massive technical effort. And we are already seeing the results. I mean, agents deployed at Macquarie Bank are already cutting false positive security alerts by 40%.
That's a huge number.
It is. The Deep Research agent we talked about is a real-world example of this autonomous power. But the core question of how fast these agents can evolve still comes down to data and training.
And that's the scary part, isn't it? If the agent is the future, what happens when the agent can write its own curriculum?
Well, this is where we have to connect the present to the immediate future with DeepMind's work on Genie and Sima. So Genie is the generative world model, and Sima is the simulated agent. Their research outlines this infinite training loop.
An infinite loop.
The Sima agents, they're driven by curiosity. They navigate worlds that are generated on the fly by Genie. So every time the agent encounters a new situation, Genie generates the environment needed to teach it that skill instantaneously.
It's an infinite, customized training flywheel. It just sidesteps the data bottleneck completely.
Precisely. If AI can autonomously generate its own simulated worlds and learn instantly, we have to really consider what that means for the traditional bottleneck of data scarcity. The moment the AI controls its own data stream, the speed of capability acceleration could move far beyond anything we've ever measured.
Possibly leading to that robot revolution velocity that DeepMind leadership has predicted.
It forces us to ask, if the AI can write its own curriculum, what is the new ceiling for capability and how quickly will we hit it?
That is something to truly mull over as we head into the first full working week of 2026. We will continue to follow that convergence of world models and agents in our next deep dive. Thanks for tuning in.